So the next one that we're going to talk about is going to be the sampler info node. This one in particular is quite an interesting one. I'm going to go ahead and try and explain this to you guys in as simple as possible way that I can. I'm going to bring up my drawing app and I'm going to draw on screen. Let's have a look. Bring my Photoshop into view. And just 1 second there. There we go. Great stuff. I'm going to clear what we have over here. There we go. It's wiping this canvas nice and clean. So how this is going to work is I'm going to have to explain a few things to you guys regarding the normals of polygon surface, or essentially any surface for that matter. If we were to look at polygon surface in terms of a face, let's consider this as our face. And then this face has a particular normal direction in which the surface is indicated as the upper side versus the bottom or downside, or rather the front side versus the back side of the face. So each normal of a face is pointing perpendicular to this face, so 90 degrees from the actual surface angle. And what this indicates is it provides us information to the shader and how the lighting will catch the actual surface and reflect the light back towards the camera. So if we were to look at say a round circle or sphere, and we divide this up into different faces, for example, each face indicated by these chunks that we see over here, these are pointing their normals in a 90-degree angle away from the face. And what we need to do is we need to gather the information from that particular face normal and then give that to the sampler info node so that we can actually utilize to manipulate the way that the light is catching this particular surface. So when we introduce the sampler info node, sampler info, there we go. And this particular node has some information in how we can calculate the information coming off of the normals. My spelling is horrible today. Normal. There we go. And then we can provide that information to some sort of other node that will output the resulting info in a different way than what would naturally be bouncing off of that surface. So if we consider this as our light ray, and that light ray hits the surface, the normal will recalculate that information and the light will bounce out back away from that surface. So what I'm going to do is I'm going to utilize the sampler info node to gather the information from the normals and then send that information through another node, for example like a ramp, and that particular ramp will give us a way to control how the light hits the surface based on facing angles and direct or angles pointing away from us and facing towards the camera. So essentially this will provide us the ability to create some sort of a Fresnel effect. For those of you that does not know what Fresnel mean, it's simply a word that describes how light drops off of the angle that we're looking at it. If we were to stand close to some sort of a lake and we look down straight into the water, we will essentially be able to see our feet. And if the further we start looking away from from the water towards the horizon, we'll start seeing more reflections of the light hitting the water, and thus producing a much more clearer, clearer type of reflection. So this Fresnel effect could definitely be accomplished utilizing the sampler info node. So what I'm going to do now is actually demo this for you guys inside of Maya. So the sampler info node, as we have a few different properties over here, we can utilize for this node for quite a few different effects, but in particular the one that we are trying to look at is this facing ratio. So what I'm going to do is I'm going to take this sampler info node together with some sort of a ramp texture. I'm going to go to my 2D textures, scroll down to the ramps, bring this into view. There we go. Bring this guy over here, move these guys off a bit, make some space, there we go. And we're going to take the resulting info from the facing ratio and connect that to the U or the V side of our ramp, and then the out result of that will now go into our colors. So let's see how this works. I'm going to click on this guy, and as soon as you click over here, it's going to give you the option to choose which of these would you like to use. I'm going to choose facing ratio. I'm going to drag this down and connect that to the V coordinates of our ramp. Then with this, if we were to look at the texture, it's not currently doing much for us. We have to essentially be able to apply it to a polygon surface so that we can see the resulting effect on our normals. So the out color from here, I'm going to drag this out and connect that to color. And as soon as we do that, you will now notice in the material viewer as well as on our surface that the outer edge of our model appears to be much darker than towards the center. So if I quickly go ahead and preview what the normals look like on a polygon surface, if we go to display, polygon display, and then turn on face normals, we can see that on the face normals we have these little arrows pointing 90 degrees away from each face. These normals are the essentially the bits of information that the sampler info node is taking a hold of, and then based on those angles and based off of those values, the facing ratio will indicate how the color of our ramp will be mapped towards the edge of our model. If we were to look at the sphere from this point of view, we can see that in the center the normals are pointing pretty much straight towards the camera, towards us, and then as we start looking more towards the edge of our sphere, we'll start seeing that these guys are pointing further and further away from us. I'm going to go ahead and make the display of these facing normals a little bit bigger. I'm going to make the length of these guys quite a bit longer and say face normal size. Bring this up a bit, hit apply. Let's see if I can make this longer. Let's turn that on, obviously. Hit apply, and there we go. That might be a bit too long. There we go, great. Now we can clearly see that these normals in the center are pointing straight towards us, and as we go further and further away from the center towards the edge of our object, these normals are pointing 90 degrees away from us, and thus the sampler info node connected through the ramp will take a hold of that information, and based on the color of the ramp we will have the ability to change the way it's appearing on the surface or towards the edges of our object. So I'm going to go ahead and just do a quick display reset so that we disable the normals and expand my view again. From this further onwards, I'm going to select my ramp and bring up my black points closer towards the center, and as we do that you can definitely see that the drop off of the color is now mapped much closer towards the center, thus producing a very dark edged kind of effect based on our color. We can also go ahead and change the color scheme if you wanted to. Let's say we want to map some sort of a blue tinted color towards the edges, and then in the center we want to have some sort of red tint. And so we can definitely do something like that. This particular node, in my opinion, I find it very useful if we wanted to create some sort of a velvet type texture, or if you wanted to produce some sort of an X-ray vision kind of effect where the colors are more transparent in the center than they are towards the edges, so that we can create some sort of a X-ray kind of skeleton-like effect. So definitely make use of the sampler info node to give us some pretty nice looking results and create some sort of a interesting Fresnel effect on our texture. The next node that I want to talk about is going to be our gamma correction node. And to understand the gamma correction node, I'm going to keep it very simple. At some other point I will start talking about how this particular node is useful in linear workflow methods for advanced rendering and so on. But for now, all we have to know is the gamma correction node provides a value and it provides us a gamma input, and we can give it a specific gamma input, and that will remap the colors so that the out value coming from the gamma is corrected accordingly. So to give you guys an example of that, if I were to get rid of the sampler info as well as the ramp, and we were to take our initial texture over here, we can see that the texture is out color. We can map that right into the value because we have a value slot that utilizes some sort of a texture. It reads the RGB values without any issue, and the out value is currently set to 1, 1, and 1, meaning there's no current change of our values coming in or going out. As soon as I drag this and connect it in, you will see that the result hasn't been changed at all. So as soon as we start changing the gamma to, let's take an example of 1.5 on all three outputs, we can see that now we have remapped the colors on our texture to be definitely much brighter than the original inputs. It's just worth noticing that this particular node is probably going to be very important once we get to our linear workflows and when we start talking about color spaces and color management profiles inside of Maya. The gamma correction node is, if we look at the little thumbnail over here, you can see it provides some sort of a ramp effect where we have three different colors: the green channel in the middle, the red channel at the top, and the blue channel at the bottom. This indication is essentially describing some sort of a curve adjustment of how these colors are being remapped so that the output values are more contrasted or more desaturated and brighter, if I were to put it in those terms. I will show you guys at some point how we can utilize this particular texture. The next texture that we haven't, or rather the next utility that we haven't talked about at this point, is our luminance utility node. So I'm going to quickly try and find that. There we go. There's our RGB to luminance node, and this particular node is simply a converter of values. So it essentially remaps color from the one side and it outputs the color on the other side as a grayscale map. As soon as I do that, you can see now we're trying to connect that to our shader, and it's not giving me the ability to connect that to the color channel as is, purely because the out result from our luminance node is a single value instead of 3 different channels. So from the one side, it brings in all 3 channels independently, and the out result on this side is going to be a single float value. So if we wanted to connect them all 3 to the R, G, and B channel, then you have to do them independently. So as soon as I drag this out and I connect that to the red channel, it allows me to connect that one at a time. Green channel, and then finally the blue channel. Once I've done that, you can now see that we have successfully converted our color image to grayscale. That's then exporting 3 different sets of values into our red, green, and blue channel of our color on our shader, and the result is accordingly just a grayscale map. So this node in particular I find is probably the easiest node to convert values quickly between the different utilities and then passing them on as either single values, and then you can choose whether you want to connect them as a single channel to a single attribute, or have all 3 connecting into one set of RGB values. I hope that makes sense to you guys. I definitely, like I said, I find this one very useful, and we'll kind of put them together in a scene later on and actually figure out how this network works together. I'm going to go ahead and there's one node in particular that is worth mentioning as well, and this is going to be our, let's have a look. I'm trying to see if I can find. Right, so we have a plus, minus, and average utility node as well. This node in particular is an interesting one because it allows us to add up values together. So how this works is we have 3 sets of inputs, and we can choose whether we want to have them as single inputs, double inputs, or 3 channel inputs. So if we were to quickly jump to Photoshop and explain this to you guys, I'll show you how that works. I'm going to fill this canvas with white. There we go. And I'm going to write in black. There we go. Great. So the plus minus average node, think of this as our, let's say, image. So I'm going to call this T1 for texture 1. And we have a plus minus average utility node. So plus minus, let's say, average. And we have a texture 2 as well, T2. So what this utility node does is, based on the mode that we choose, whether it's a plus, minus, or average, we can combine these 2 textures together through the utility node, and the out result would either be added, subtracted off each other, or just blended together to create a new value. These utilities were intended initially for texture-based kind of workflows or shader-based workflows, but it could also be utilized to add up values for objects' positions in 3-dimensional space. So if we wanted to have, let's take box 1 and we have box 2, we can take these 2 values. Say this one has a value of, on the X channel we have a value of 5, and in this box our X value for the transforms are combined value of 12. Then the out result of these would be added up, subtracted, or averaged together, and then the value would be a new position in 3D space that equals the added, subtracted, or averaged result of these. So that could be, let's just do a question mark for here. So that's definitely a way that we can utilize that for repositioning objects or averaging them together. Especially if you have some sort of a mechanical system and you want to average the results so that the mechanical joints of an object works together and stays in place without breaking or so on. Right, so let's have a look and see if we can utilize this for some sort of a texture-based workflow. If we were looking at our plus minus average, I'm going to take my texture 1 and I'm going to create a new input. You can see by default it has an input 1 and it has a slot 0 right here in the center. So what this simply means is Maya starts off with its array system as 0 being the first number in our list, and as soon as we start adding multiple nodes together, Maya will automatically add the next one to the one that's up from there, so being input 1D, input 2D, input 3D, and so on and so forth. But the first one will always be a value of 0. So if we were to, or rather slot 0, so I'm going to connect that in. You can see by default it's going to give you an error saying the cannot be connected to plus minus average 1 or 0D, and the result of that is because we have 3 different color values trying to go into here, so it's not going to be able to add them up together. So if you wanted to do that, the 1D type of input node will not be successful. It's not going to work, so we have to utilize the input 3D. So if you open that up, you can see it's also making use of an input 3D slot 0, but it has an X, a Y, and a Z. You can also consider this as a R, G, and B. So let's see if we can connect this guy into that input 3D. Great, that was successful. We have connected that up together, and we can see that input 3D is now part of that input nodes. And let's take the second texture, being this one over here. I'm going to expand its attributes by pressing 3 on this little node, and I'm going to drag the out color into the same input 3D, but as slot 1, you can see there's a 1 value over there. I'm going to connect it in there. So now we have the results of corrosion and the painted layer working together. And if we change the mode of the operation to subtract, these values would be subtracted from each other or averaged together, so that the resulting values going from the out 3D side is now mapped to color, and we can see the combined results of those values. So this is essentially what the plus minus average utility node does. It's giving us the ability to either have single inputs, double inputs, or triple inputs. And as we know that most of our textures are exporting some sort of an out color that has a red, green, and blue, these could be considered as a three-way channel, and thus we have to use the input 3D as a choice for our plus minus average utility node. So the X from slot 0 is added to X on slot 1, and then the added results will be X X2, if I can call it that, so that you have the outputs of these combined together. The same goes for input 3D for the y-axis is added together with inputs 3D Y on slot 1, and that is exported to be a combined result for that. So I hope you guys can definitely utilize for your texture workflows, and I will see you guys in the next one. The next one we're going to start talking about the the projection utility nodes inside of Maya, and it's essentially a UV list based texture workflow. It's a way for us to convert some sort of a 2D texture into a 3D based texture projection that we can then move around in our 3D space and then apply the effect of a 2D image across the whole 3D object without needing to create UVs. So see you guys in the next one. Cheers.